Hello, welcome to MFM2PI, 5th unit trigonometry. This is the second part of our 7th lesson on solving right-angled triangles. So we're going to work through the last two examples now. We're going to start by creating our little table over here. Angle A, angle B, angle C, side little a, side little b, side little c. And let's get down what we already know. So we already know that side little a is equal to 10, that angle C is equal to 90 degrees, and side little c is equal to 13. So now leaves us three pieces of information: angle A, angle B, and side little b. So let's start with, let's go into the angles first. Let's go there. So let's start by picking a reference angle. Let's use B as our reference angle. So from there, our hypotenuse is 13, our opposite, side little b, and our adjacent is equal to 10. So let's do number one over here. Number one, we'll call this find angle B, and we'll write out our SOHCAHTOA. And looking back over there, we see that we have hypotenuse and we have adjacent. So hypotenuse and adjacent, that's no tangent, that's no sine, that's going to be cosine. So let's write out the cosine of angle B is equal to the adjacent side, which is 10, over the hypotenuse, which is 13. And now we are going to find angle B by taking the cosine, which is taking the inverse cosine, or the cos negative 1, of 10 over 13. And that is what I'm going to type into my calculator. So the second function, cos of 10 divided by 13, is going to give us 39.7. So we will round that to 40 degrees. And we'll put that into our table. 40 degrees. And let's go get angle A now, because that's pretty straightforward. Number two, find angle A. And angle A, of course, we can use the sum of interior angles to figure this out, which is 180 degrees minus 90 degrees minus 40 degrees. And that will give us angle A equal to 50 degrees, which we will also put in our table. Here's our 50 degrees. Last thing we want to do is go get side little b. And let's do that. Let's use a Pythagorean theorem, I guess. We haven't done one like that yet for a non-hypotenuse side. So we are going to do number three, find little b. And we will write out our Pythagorean theorem as c squared equals a squared plus b squared. It just so happens that we have the hypotenuse this time, so that'll be 13 squared equals, we have side little a, which is 10 squared, and we are after b squared. So let's do a little algebra first. We'll have our 13 squared minus our 10 squared will equal our b squared. And let's type that into our calculator now. So 13 squared minus 10 squared is going to give us 69 equals b squared, and b then will be the square root of 69, which when we type in gives us 8.3. So 8.3 equals b, and we'll put that in the table. 8.3. And that finishes up our third example. Okay, grand finale, here we go. Final triangle starts with a list. Let's make it happen. So we're going to get angle A equals angle B equals angle C equals little a, little b, and little c. Let's see what we've got here. So side little a will be equal to 8. Angle C will be 90 degrees. And angle A is 49 degrees. There we go. And that leaves us, as usual, three pieces of information: angle B, side little b, and side little c. So let's start with angle B. Make that happen. So angle B, I'll call it number one, find angle B. And again, it's nice because this is our third angle. Provided two other angles, then angle B will be equal to 180 degrees minus 90 degrees and minus 49 degrees. Angle B then will equal, we'll type that into our calculator, 180 minus 90 minus 49 will equal 41 degrees. And we'll put that into our table. There we go. And now we can go at any side that we'd like. Let's just go after B because alphabetically that feels good. So let's go to B. I'll pick 49 as my reference angle. So from there we have our hypotenuse, our opposite, and our adjacent side there. So let's write ourselves out a SOHCAHTOA as we go find side little b. To find little b. So we've got our SOHCAHTOA. And what have we been given? Well, we have, from our reference angle, we have our opposite. There we go. Sorry, Ka. And we would like our adjacent. So that's going to be TOA, sorry, sine. So let's do the tangent. Our reference angle was A. Just going to have to squeeze this one in here. The tangent of A equals the opposite side, which is 8, over the adjacent side, which we don't know is little b. So let's set this over 1. And to save a little space, I'm just going to put in right there what angle A is, because we're really close to the bottom here. And angle A, of course, was 49. And we're going to cross multiply here. And that's going to give us tan of 49 degrees times b equals 8. And to get b alone, I'm going to divide both sides by tan 49. I totally ran out of space here, friends. Oh well, we're going to go sideways. Don't do this at home if you can help it. So I'm going to get then angle B, or side B, equals 8 divided by tan of 49. So let's do that. 8 divided by the tan of 49 degrees, and that's going to give us 6.95, so 7.0. That's side little b, 7.0. And last but not least, we're going to squeeze in here and go get side little c, and we'll use our Pythagorean theorem for that, just to keep it fresh. So we have number 3, which is find c. And let's use our Pythagorean theorem. C squared equals a squared plus b squared. Of course, in this triangle, again, we don't have our hypotenuse. That's what we're looking for. So it's our c squared equals our 8 squared plus our 7 squared. C squared will equal, let's do it as our calculator, 8 squared plus 7 squared is going to give us 113. And the way to get c is to square root both sides. And that will then give us c is equal to 10.6, which we will put into our table. 10.6. And that is the solution for the last triangle there. So if you use these last two examples, fantastic. Now is definitely the time to head over to your self-assessment. Get that done, check it with your teacher, then do the mastery test, followed by the last lesson, which is lesson number 8, which is going to be some real-world trig questions. So good luck.